Hi, this is Jeff Coronado on behalf of JCSE, and this is Bridging the Gap. So this is an ongoing series of structural engineering design tutorials that we have here at our office that's intended to assist young structural engineers. And by young structural engineers, we mean structural engineers that have been out of school for a couple of years, maybe they're within their first couple of years after having graduated, um, or they're in their last year, maybe their last 2 years of school. I think, as we all know, structural engineering is very limited. There's very limited spaces, very limited openings, I guess I should say, compared to the number of graduates that there are. So it's very competitive, and any edge that you can get, any traction that you can get, will serve you well when you're actually trying to get into industry. And for those of you who are in industry and you're still early in your career development, you know that it's a struggle. You know that that again, it's difficult to gain traction. There's a lot that industry expects you to know. That offices tend to not have the patience to explain to young engineers. They expect them to kind of gain traction on their own. So this is intended to help those type of young structural engineers out. Okay, so with that in mind, let's get started on today's session. We're entitling it Joist Cantilever Splices of Joist. So the question is, how far does the backspan have to extend if we want to splice a cantilever joist? All right, so this is a question that's coming in from a young structural engineer, one of our young engineers. Um, and let's get into this. However, let me just kind of a standard admonishment. Get all you can from the tutorial. Don't be jumping around. Don't get the one piece of data that you think you need, because the reality is what we're trying to do is to arm you as structural engineers. We're trying to get you to think like a structural engineer would think. Obviously, the sooner that you are able to kind of immerse yourself into that, or I guess I should say digest that type of thinking, the sooner you'll be in that situation, and you won't have to be depending on tutorials and so forth to help you out. So try to digest everything that's given to you in this tutorial. Take notes if you need, what have you. Like I say a lot of times, if you do things right, you only need to do them once. So with that, let's march forward. If you have any questions on anything that we say, by all means, leave us a note at the end of the session with any questions. We'll try to point you in the right direction, clarify for you anything that you needed clarified. If there are other tutorials, which there usually are, kind of sistering tutorials, if you will, that cover similar topics to the one that we're covering here, we'll point you in that direction so that you can get kind of like the rest of the information, if you will. Again, if you have any other questions, we'll try to specifically tackle this task on this one, and not kind of jump over to other things that are covered in other tutorials. At the end, if you found the tutorial to be helpful, sure would appreciate if you give us a thumbs up. Again, any comments, any positive comments, any positive feedback or negative feedback, whatever, right? I mean, it's all good. You have any comments, any suggestions, by all means, we'll take a look at it and see if it's something that we can incorporate. If you do find the tutorial to be helpful, go ahead, by all means, go ahead and subscribe to our channel. I believe that there's a flag, something that you toggle or something. I'm not real good at YouTube stuff, but there's something there that you can toggle on, so that you get notified of tutorials on our channel that get uploaded, and that way you can stay current with the tutorials that we're uploading. Okay, with that in mind, let's take a look at the section that the engineer sent us. And sure enough, it's kind of what I expected was the question. Really what they're after. So this looks like a roof framing. Okay, so we've got a roof rafter here, kind of extends, obviously. And I'm going to guess that there was some kind of damage out here, out in the tail part of the rafter that extends beyond the exterior bearing wall. So this is the exterior, oops, well, that's okay. This is the exterior bearing wall that I'm showing you in blue. So the portion in red, the portion that cantilevers beyond the exterior wall, has some kind of damage, probably, who knows, fire damage, who knows, some kind of damage. So we need to, or maybe dry rot, we need to sister a splice to this cantilever. Looks like that's what the engineer is trying to do. So really what they're asking is this particular ratio here. So if the cantilever extends 2 feet beyond the exterior wall, then I think the question that they're asking is how far inboard does the splice need to go? Okay, so if you are having a hard time visualizing this, let's look at this like in plan view. So basically, all we're really doing is if let's say this is the wall. Let me draw the wall here. So this is the wall in plan, right? And then over that wall, we're going to have the existing rafters. Well, that's okay. We're going to have the existing rafters that kind of cantilever over the wall in this fashion, right? So these are all the rafters, the existing rafters that are cantilevering over the wall. All right, now we have to, let me see, go to red here. So now, let's say that this part is what's damaged, and that's what the engineer wants to splice that damage. So they would like to add another piece of rafter, probably matching the depth of this member. But then here's the question: does it go this far? Does it go this far? Does it go this far? Clearly, I think for economics, they don't want to go all the way back, right? So the question is, how far back do they need to go? And okay, so let's tackle that question. How far back do they need to go? Well, I'll tell you this. As an old guy, what I would tell you is this. If this is, let's call this L. Let's call the overhang L. If the overhang is L and we extend this splice 4 times L, nobody's going to question that. Okay, that's the safest way you can go. Nobody's going to question that. Well, I shouldn't say nobody. You know, can always find somebody who's unreasonable, but real good chance nobody's going to question that. That's a safe extension. Anything less than 4L, you're open to somebody questioning you. That doesn't mean that you're wrong, just means you may need to justify it. Here in this case, it looks like the engineer for right now is showing basically what amounts to a 2L extension, right? So, okay, sure enough, we'll challenge that, you know, show me that 2L will work. So how do we show that 2L will work? Well, gosh, let's just go back to our, fundamental statics. This is just third year civil engineering, right? Goes back to statics. What we have here is, so let me draw the elevation of our rafter. So, and I'm not going to angle it. It really doesn't matter. So I'm not going to angle it. Let me put it out here. Let's say this is, in fact, let's say this is our splice, not our rafter. There's our splice, right? So we've got a support, a simple support right here and a simple support back here. We have, you know what, for this exercise, here's how I would do this. For this exercise, I would simply look at the uniform load that's over the cantilever. All right, so what's that going to be? Well, so now what we're looking at is basically, well, first let's look at the dead load. So what's the dead load of this roofing assembly? Well, you know, I can say that's maybe what, probably on the low side 10 pounds per square foot, probably on the high side 15 pounds per square foot. That's not the purpose of this tutorial. So for that, I think just let us know. We'll point you to tutorials that cover loads. But let's just say for right now that we're talking about 15 pounds per square foot. Again, if there's anything that I say that's not clear to you, that's probably because it's covered in other tutorials. Let us know. We'll point you in that direction. Okay, so I'm going to kind of go through this a little bit, maybe a little bit quick. Again, send us at the end, leave us any questions that you have, and we'll try to clarify. But here's how I would think of it. We've got 15 pounds per square foot. The live load on that overhang is going to be 20 pounds per square foot. That means my total load there, my total uniform load is 15 and 20. I've got 35 pounds per square foot. Now let's assume that the rafters are spaced. So now I'm looking at this distance. Oops. My rafters are spaced, let's say 2 feet apart. Yeah, makes the math easy. If your rafters are at 16 on center, okay, then the math is, you know, you have to do the math for 16. But if the rafters are at 2 feet apart, then I'm multiplying those, what did I say, 35 pounds per square foot times the rafter spacing, 2 feet. I've got 70 pounds per square foot. So now what I'm looking at is what is the moment induced by those 70 pounds per square foot. Well, again, this is just junior level statics, right? 70 pounds per square foot times the overhang length, which is 2 feet. I've got 140 pounds times the lever arm, that's 1 foot. That's 140 times 1. My moment here is 140 foot-pounds. So 140 foot-pounds. If I, well, okay, let's use, well, here the engineer has a lever arm of 2L, 4 feet. However, notice how the nails, the connectors here are spaced out. I believe, let me undo that. I believe there was one here. There's another one here. There's another one here. I might have covered one here. You know what? How about if I just look at one connector? So meaning this one. So I'm going to say that I've got 140 foot-pounds, and I'm going to divide that by this distance, the distance between my supports, right? Distance between my supports gives me my reaction at the back end. So that's 140 divided by, oh, we don't exactly know this distance. We know that the total distance is 4 feet. However, this last nail isn't at 4 feet. You know what? What if I conservatively say or figure this is 3 feet? So I've got 140 divided by 3, right? That gives me what? 140 divided by 3, 30, 35, 40, let's say, 40 max, right? So I've got 40 pounds on that outlier nail. Is this connection going to be good enough? Sure, right? I'm going to bank on that one nail being able to resist 40 pounds. Look at what I have ignored. I haven't taken into account these nails here, right? I haven't taken into account the additional nails that are in this connection. I also did not take into account that there is a moment, I'm sorry, that there is load on this portion of the rafter that resists that 140 foot-pounds. So this is a kind of a worst case scenario that we just kind of real quick and dirty, almost literally in my head, right? Like I don't have to do any calculations for this. I shouldn't say that. I don't have to do any rigorous calculations that I'm going to submit on paper. No spreadsheets, nothing else, right? This is just in my head to make sure that in my head, I know it works. And yeah, I think what I'm seeing is in my head, I can justify the numbers and I can show that this extension will work. Okay, so that's kind of how we would determine the extension. The need for the extension is simply to increase your lever arm to resist that overturning moment, if you will, that we calculate. That's the purpose of why we need to extend back. Clearly, the more that we extend back, if we make that 4L 6L, if we make it 8L, the further back we go, the further back the distance is to, let's say, this last nail, the less force there will be on that nail. So that's why we extend the cantilever into the main span of the rafter. All right, with that said, let me clear the screen here and just make sure that we're not missing anything else. In fact, you know what, let's kind of check this as we go. So here we've got an existing 2x roof joist. Okay, I wouldn't do this. I can see here the engineer might be creating some ambiguity because they're saying this is the existing roof joist, but in reality, I believe they're pointing to the splice, right? Because I don't know, like all of this, I think is the splice. Really, this specification should go out here. This engineer needs to extend this, right? And then this specification would go out to where it's really the existing part of the rafter. Because right now, the way they're pointing to this, they're pointing to what's really both of them. Both the new part of the rafter and the existing part of the rafter are there. So in order to be clear, I think this engineer needs to extend that specification, extend the length of this rafter, do things here a little bit different to make sure that they don't cross up the contractor. All right, let me clear that. So the engineer is saying they've got new 3/4 inch sheathing, okay. They have a bubble here, but it's not filled in, so I'm not really sure what they are doing there. New 2x6 rafter tail splice, okay. But then you see the problem, right, that we were talking about earlier. Both of these specifications are pointing to the same thing. So you don't want that kind of ambiguity or that kind of confusion. 16Ds at 8, staggered. Okay, staggered, meaning they want the nails to go up and down, right? Up and down. So sure, that makes sense so that you don't split the wood. The idea there is that, let me clear this. The idea there is you've got your wood fibers. Well, you got your wood fibers, right? They're going along here. The idea is that if you come in here and you drive a nail into the same line, right, you can potentially end up with a pretty big split going there. So what I've drawn here is not a split, right? It's just a fiber. But if you put several nails in close proximity into the same fiber or between, let's say, the same two fibers, you might create a split. So that's why we would stagger those nails. Okay, so that makes sense. 16D staggered. You know what? I'm not sure about the 8. I mean, we're seeing how just one nail was adequate, right? One nail 3 feet away from the support was adequate. So you know what? If we do these 16D at 12, that would probably be more than enough, right? 16D at 12 to join the cantilever splice to the main body of the rafter. I don't understand what the engineer is doing here. I don't understand this. There's a hidden line there. Okay, wow. If I were the contractor, I'd be confused by that. You know, let's see. If we look at this in plan view, again, here's the wall. Here's the wall. Here is the existing rafter. All right, there's the existing rafter. Like, if I'm the contractor, here's I think what how I would interpret this. And I'm not sure. I'm not really sure. But how do I interpret this? Like, this is the splice. Like, the splice extends beyond the rafter. Like, is that what this hidden line is here? Is it the edge of the existing rafter that goes there? Not really sure about this line. Existing 2x solid block notch. You know what? I don't think you can notch this. You know, if you've got a block here, if you've got a block, actually, yeah, think about this block. This block would have been going here, right, up to the existing rafter. And now you want to get this, now you want to get this splice in, right? So what the engineer is trying to do here is notch this block to get this rafter in. Maybe that'll work. Problem is that rafter, that block has nails connecting to the rafter. So you're kind of cutting those nails. You know what, this might work. I don't know what, I don't really know what the contractor would prefer to do. I don't know if they would prefer to just knock out that block and put in a new block, or do what the engineer is suggesting here, which is to kind of get real surgical, if you will, with very small hand tools and cut a portion of this block out, so that they can slide in the new splice. But you know, I suppose this is okay. And if the contractor comes back and says, hey, do I need to do it this way? Do I need to saw cut that rafter, or just cut that, I'm sorry, not the rafter, the block, cut the block, or can I just remove it and place a new block? Sure, if they ask us that, sure, you can do that, right? But I suppose there's nothing wrong with how the engineer is specifying this block to be treated. Okay, let me make sure that we've covered everything here, or that there is anything else that needs to be covered. No, that's it. So, so again, if you enjoyed this tutorial, would appreciate the thumbs up, would appreciate you leaving us any comments that would be helpful in terms of any suggestions that you have. And if this was helpful to you, by all means, subscribe to our channel, the JCSC LLC channel, and then toggle so that you can be notified automatically of whenever we upload any structural engineering design tutorials. Okay, real good, guys.